Okay, so looks like we have a good mix here of teachers, students, and parents. Always good to see that. A lot of Wolfram language users, always good to see that too. And it seems like almost everyone is interested or thinking about introducing coding into the classroom, which is perfect for us. So let's go on with the presentation. Like I said, my name is Rob Morris. This workshop is designed for educators. We are introducing the Wolfram Programming Lab, something that we launched last month. We've been working on it for a while, and it's really designed to teach coding in the Wolfram language. As we go on with the workshop, if you have any questions you'd like to post, there's a Q&A pod, so please feel free to post questions in there, and we will try to get those answered as well as we can. There will also be a significant Q&A portion at the end. We want to leave a lot of time to talk to you and answer your questions. Okay, so first off, what is Wolfram Programming Lab? Like I said, it is designed to teach you coding in the Wolfram language. I tell people it is the place you go to learn the Wolfram language. Do you want to learn the Wolfram language? Yes, then you should check out the Programming Lab. We've also designed it to foster computational thinking skills. We recognize that computational thinking and coding are going to be a big part of student curricula now and certainly in the near future. So we think that the Wolfram language is a great first language to foster that, and we want to engage students as much as possible with the Wolfram language. So at the heart of the Programming Lab are what we call explorations. Explorations are sort of mini lessons. They start at very basics and they build you up to a goal. You create something, you might create a web page, you might create some sort of interactive GUI object. They have all the steps laid out, and they have details that you can look at if you're looking for more information. They can link to documentation. My colleague Adriana Rose will be showing you exactly how they work, so I'll let her talk more about those. Right now the explorations are focused sort of at the middle and high school level, but there's a lot there. Certainly younger and older audiences will find something to interest them. And we're adding more all the time. So like I said, we're relatively new and we've got a lot of things in the pipeline for the Programming Lab, new content being one of the first things. So we have Programming Lab for desktop, but really at its heart, it's a cloud-based product. It's something that we want people to be using on the go in the classroom. We want them to collaborate and share with it. It's really designed with the cloud in mind. When you're learning the Wolfram language, the explorations are a great place to start. They give you a sort of sense of a certain coding goal. If you want to, let's say, draw some circles and color them in with varying opacity or something like that, or solve mazes or things like that. They're great for these sort of mini projects. But if you want to learn the language in a more structured way, then you're going to want to check out Stephen Wolfram's new book, An Elementary Introduction to the Wolfram Language. So this book came out, I think, in December, and it is one of the, I think, best introductions to the Wolfram language. It's it starts out very, very basic. You don't need to know anything about coding. You don't need to know anything about math. Basically, you start with 2 plus 2. There are about 40 to 50 sections, and if you work through the whole book, you will have a very complete sense of the Wolfram language, and you'll be a fairly proficient programmer if you work through the whole thing. So we built that book into the Programming Lab, and Adriana will show you this. We think that it's a great way to really get started with the language. Try the explorations. You work on them in class with students and so on, but If you really want to learn the language, then we have a whole course for the language built right in. Okay, so with that, I will turn things over to Adriana, and she will show you, how the programming lab works, what it looks like, and walk you through the different steps.
Thanks, Rob. Okay, let me go ahead and get my screen ready. Okay, hi everyone. Again, welcome to the virtual workshop for educators exploring the Wolfram Programming Lab. This is a very exciting time for us here at Wolfram because we've been working on this for the last several years. Aish, who's here with me as well, has been going to schools, libraries, other after-school programs for elementary, middle, and high school students, and have been exploring working with the programming lab. And we've had an enormous positive response to students using the programming lab. So what I'm going to do is just dive in and really explore the features of the programming lab, where you can go to get content, and how you might use this in your classroom. So like Rob was saying, we have two different versions. We've got the signed in version, which is where I am right now, or we have the cloud version. So the reason why I want to mention both of those is, if you're giving, let's say, an hour workshop in the Wolfram language, maybe you're visiting a robotics team, or maybe, you're going into a classroom and just giving sort of a 1-hour spiel about it, you don't want to spend all this time setting up IDs. They don't need to save their work. It's just a 1-hour introduction. So the Open Cloud, the Open Programming Lab, is a really nice tool for that type of implementation. And so it would just be lab.open.Wolfram Cloud, and you can just go ahead and start programming in the Wolfram language right away. I'm in the signed in version, so when I went to lab.wolframcloud.com, it asked me to sign in with my Wolfram ID, which all of you have. And now I can save my progress on my explorations, as well as create some new notebooks. So if I wanted to explore, with a blank slate, I can go ahead and do that, and then also be able to explore some of the coding in the elementary introduction to the Wolfram language. So that's getting to the programming lab. Now that I'm here, you can see that obviously I've got 4 main options to choose from. The very first one, as an educator, would be to, don't play that, would be to click on the video. This is just an overview of some of the things that I'm about to say right now. You can forward it along to maybe your principal, a colleague, a parent, saying, okay, this is what this thing is, here's how you use it, just the general features that you'll find in an exploration, in the elementary introduction, and so on. The next thing that I'm going to focus on, we'll get to the elementary introduction here in a moment, but I'm really going to look at the explorations. So the very first one that you'll want to do is the getting started exploration, which is labeled try it yourself here. So there's 2 ways that you can get to it. Obviously you can just click on this tile here, or if you notice I'm moving my mouse up to the top bar and we have this star icon, and if I hover over it, you'll see that this says explorations. So if I wanted to open up a whole menu of explorations, I could either pick an exploration or click on this explorations icon. You can see that the getting started exploration is also available in this sidebar. So I'm going to go ahead and close that. So let's open up the try it yourself. Okay. Unlike the rest of the explorations that you'll find in the programming lab, the getting started is just really, how do I use the Wolfram language? What are these explorations going to look like? So it's just exposing both teachers and students to how an exploration, this type of activity, is going to go, and also introducing some basic syntax features for the student or teacher. So again, I'm going to go ahead and close my exploration menu. So getting started, again, just some very brief introductory type lines of code. So you can see that the exploration is divided into steps. They're labeled by step 1, 2, 3, and so on. They range anywhere between 5 to 8 steps. We don't want to get it too long. So obviously, when you're in the Getting Started notebook, if you've never used the Wolfram language, we really need students and teachers to be able to evaluate. So obviously, I click anywhere inside the code, press Shift-Enter or Shift-Return, and oh, we've got some magic here. I've actually ran my first line of Wolfram language code. Now, there are two things that you can do from here. Is I can actually edit this code. So if I was doing this in the classroom, one of the common things that I would say is, okay, we've done 2 plus 2. The next thing that I want to do, let's do 123 times 456. And then let's evaluate. And now you can see we've changed the code. It's not a big deal, and we can move on. So this step was just exploring that this is how we evaluate. Now, obviously, most of you are familiar with the Wolfram language as you demonstrated in the polls. But I am going to run through this as if I was in a classroom, just so you can see the various features and things like that. So the next step here in step 2 says get a list of numbers from 1 to 10, try other numbers than 10. The code is already there for students and teachers to start off with. We wanted students to feel successful in perhaps a new discipline like computer science or introducing computational thinking. So we didn't really want to focus on the syntax, but more so what can you complete with just a little bit of Wolfram language code. So obviously the hint here is to demonstrate that I can get a list of numbers from 1 to 10. You'll notice that, and it may be hard to see on my screen when I share, but if you go and take a look at this on your own, you'll notice that the 10 has been highlighted in a light yellow. This is to indicate what you're supposed to change. So we said try other numbers than 10. This is the thing that we're referring to. So instead of 10, I'm going to go ahead and delete that. And then now you can see it's asking for parameter here, and now I've calculated the range of 200, and I can go on and play with other numbers from there. Let's take a look at the next step. So in this step, obviously draw a size 100 disk, try other sizes other than 100. You can see that this is the thing that we're asking students or teachers to edit. So let's say that I'm in a classroom and then all of a sudden I want to delete and then I want size 50. Oh my gosh, it's all the errors. I mean, I messed this up. I'm a student. I don't know what's going on. I'm screaming at the teacher, what happened? And I need help. So a really amazing feature is this restore input. Is that we know 100% that students are going to get errors. I mean, it just happens. I get errors when I code. Everybody gets errors. And so a nice feature is that we allow students to start over. So if you notice that I'm over here on the right-hand side, this second button, it says restore input. So I'm going to go ahead and click on that. And then you can see that I start over with the original code. So that's a really nice tool, a really nice feature to point out to your students so that you don't constantly get bombarded with, fix my code, what's wrong with it? If you messed up, then you can always start over in the exploration. And step number 4, I'm going to go ahead and take a look at this show hide detail. So get a picture of a horse, get pictures of some other common animals. If you're not familiar with the Wolfram language, you'll see that this looks a little bit different. We've got these orange bubbles here. This is our natural language input. So I'm going to go ahead and click on this. So if you see this in other explorations, you can just click on it to change it. And you'll notice that it switched over to natural English aside from the proper syntax. So instead of picture of a horse, let's do a picture of a cheetah. And then again, as I learned in step 1, in order to evaluate, I press Shift-Enter, and then I get my output. For those students that are interested in learning a little bit more about what's happening, or for the teacher to sort of beef up on what's happening, we have these show high details. So if you click on this, it's not essential to the exploration, but it's really nice to get a feel for, okay, what is actually happening? You know, if you have those students that want to know a little bit more, that are interested in figuring out, okay, what is this thing actually doing, it provides more details about the code that's in that particular step. Let me go ahead and close that. Okay, the last step here is apply an oil painting effect to a picture. Try some other pictures. So like the ones before, I have image effect, I have my line of code, everything's properly formatted, the syntax is great. So if I was a student, I could just hit Shift Enter and okay, there's my result. Now another aspect in show high details, so let's say I open this up. To try image effect on a different picture, delete the picture, okay, blah, blah, I'm not going to read all that, but you'll notice that image effect is bold. And this is going to lead to our documentation. And there's several ways to actually get to the documentation. So if you see a function that's bold, I can click on it and it'll automatically open up the documentation on the right-hand side. Another way to get to that is if I hover over my function, so I'm in the exploration here, if I hover over it, you'll see that there's a little I for information bubble, and if I click on that, obviously it's going to still open up the image effect. And yet another way to get to the documentation is I could run a search for image effect and produce the results in documentation. So for you as an educator or for your students that are looking to get more information, let's say instead of putting another picture there, let's try another effect. So I could just go and, you know, the Wolfram language is immensely vast. There's no way that you're going to know every aspect of the language. So being able to utilize and reference the documentation is going to be essential. So I'm looking at image effect. You can see that there are examples here. This one is of a charcoal. If I click on details here, you can see some other effects. So let's say instead of oil painting, I do comics. And then you can go off on all sorts of tangents. So instead of, we just gave a workshop yesterday for educators in Illinois. And instead of an image of a cow, we actually used current image. So you could, you know, propose to your students, you can take a selfie with your Chromebook or with your laptop and then actually put your picture in here, and you could create a charcoal drawing of your face or a comic book version of your selfie. So there's lots of different options and different tangents that you can go on and really make it personal that the students find it interesting. So I'm going to go ahead and close my documentation here. Okay. So if I scroll down to the very bottom, in some explorations, so I would say probably in most, there is this Go Further button. I'm going to go ahead and close the exploration menu. So this is the Go Further notebook for the Getting Started exploration. And like I said, for the majority of explorations, there is this Go Further section. This is more of a test your knowledge. So using what you had learned in the exploration, can you answer these questions, or can you come up with the code and actually, you know, produce that? So calculate 10 minus 7, obviously not too difficult, but this, as opposed to the Getting Started exploration where the code was already given, now we're giving them the desired output and asking the students to actually give us the syntax. Actually code in the Wolfram language starting from scratch, you don't know anything, then actually produce that result. So that was the Getting Started notebook, so I'm going to go ahead and close some of these. Okay, so that was the Getting Started notebook. Let's say I wanted to try something else, so I'm going to go ahead and click on an exploration, and let's scroll down. We have the explorations divided by difficulty level, so these are our starter explorations, just a few lines of code that are focused on very brief sort of smaller types of things. So this one obviously is how to draw a sphere or how to draw other three-dimensional figures. Getting into some of the more complicated ones, we've got basic, intermediate, and advanced. So let's take a look at an intermediate one. So you'll notice that I have this pop-up here, and you'll see this if you actually log in with your Wolfram ID, is that it's asking me resume from previous session. Because we are working in the cloud, it's going to automatically save my progress for any notebooks that I create or for any explorations that I start. So since I've done these quite a few times, I have started all of these explorations. So it's asking me, do you want to resume working on it, or do you want to start from the beginning? Now, for everybody, we're just going to start from the beginning. I'm just saying that if you are using this in your classroom, that this is just something to be aware of that they might see. Start from the beginning. Let's try another one. Here we go. So this one's Wikipedia word cloud. Again, it's usually useful, at least with the students that I've worked with, that they're working on a smaller screen. So usually encourage them to close the explorations menu so that they have they're working with a full screen. So this one you can see that it has a specific purpose, which besides the Getting Started notebook, all of the other explorations have. They all have a goal, they all have a purpose. So this one is to create Wikipedia word cloud. So we're using the function Wikipedia data in the Wolfram language to pull in the text of the article and then use functions in the Wolfram language to produce a word cloud. So I'm going to go through this pretty fast because the reason I want to go through it is basically the end piece. So here we've gone through the steps. Okay, here's step one. We're going to get the text from the Wikipedia article. So again, you should be able to just use the code that's there. This allows for some nice personalization and interest. So, if you're in an elementary school or middle school, instead of frog, choose your favorite animal. For high schoolers or even in middle school, choose your favorite sports star or celebrity or anything that they would want to do. They can actually use that interest and bake it into the coding activity. So I'm going to go through. Again, we have all of the syntax here, all of the code is available. We're just walking the students through to say, okay, here is what you can do. Here are just a very small glimpse at what's possible in the Wolfram language. And so we're trying to walk the student through how to build up your program. Again, we have additional information in the show hide details. So like with step 3, it says get rid of unimportant words, and you'll notice that I introduced the function delete stop words. Well, maybe if I wanted to, get more information, well, how did it do that? Well, actually, delete stop words is the function that does that. And then again, building on it some more, we're going to treat everything as a lowercase. Now this is the most important piece for me, is step number 5. And we really try to do this for all of our explorations where the students are able to demonstrate or to share what they've created. This is cool. I've had students request, oh, I want to print this out, I want to have it, I want to see what I've created. But in the digital space, it's really important to actually use that. So with version 10, we have this capability to instantly create forms APIs. I don't know if any of you are familiar with Form Page, but that's another option. So basically, I can create my own little mini website that students can share with anyone. And this is very, very cool for them because not only did they run through this activity, but now all of a sudden I get a URL, and that URL goes to the thing that I created. And oh, if I want to tweak this code or if I want to use this as a basis to create other forms, I can do that. So you can see that just by evaluating this short piece of code, I've created this cloud object and it produces a hyperlink for me, so I can go ahead and click on that. And then here I have my very own web form. It's a little bear, but you can add to it. It's just the basics. And so now it's my Wikipedia article word cloud generator. If the internet, there we go. Okay. So it's really embracing the digital sense of things, that not only are they learning how to code in the Wolfram language, they're being exposed to what's available, they're exploring their creativity and their interests in a STEM-related subject, but then also going that one extra step in creating digital content like a web form. I'm going to go back. Okay, before we get, I just got a couple more minutes and then I think we'll get to Q&A here in a little bit, but I want to look at the elementary introduction to the Wolfram language. Like Rob said, the explorations are a fantastic hook, or if you're using just, you need some programming activities to fill into your STEM class, or you're looking to expose them to the Wolfram language. Here's just a brief glimpse about what's possible in the Wolfram language. The explorations do a fantastic job, and we do cover a range of subject areas. So obviously we have some math, geography, we get into trigonometry in the later sections. We have lots of text analysis, so we could bring this into an English classroom, art, I mean the list goes on and on, geography, etc. So you can bring these explorations into a wide variety of classrooms or make connections to a variety of different subjects. But with the elementary introduction to the Wolfram language, this is a much more structured way to approach learning. So I envision this for a computer science course or a unit that really wants to get down to the nitty-gritty. Here's step 1, here's step 2, and so on and so forth. So when I click on Elementary Introduction to the Wolfram Language, you'll notice now that I have the split screen and I have the full book on the right-hand side with all the sections. Now what I'm going to do is, use this space as sort of my scratch work. So you can click on Create a New Notebook, and it'll create a new notebook. Let me go ahead and delete that. So now I've got my blank scratch work. I'm still in the programming lab. Obviously it's not an exploration because there's no steps, no nothing. It's just a blank notebook that I can start coding in. But now I've got my textbook essentially on the right hand side. So like we said, it's a more structured approach. So let's say that I first look at lists. So if you're going through this and using it as a textbook, you can click on the input and copy, paste, and then bring it into your scratch notebook and evaluate it there. Or let's say that you were in a classroom and you said, okay, you can see several examples of list plot. Let's go ahead and bring that over and generate your own list plot. So again, copy, paste, and I can bring it into my scratch work, and I can play around with the numbers. I can edit them, fully interactive, so I can just copy paste from the elementary introduction over into my blank notebook and explore the language that way. You'll notice that also the functions are hyperlinked, so it'll bring you to documentation. The programming lab is getting a little bit tight here, so it just helps to keep the textbook on the right-hand side, your notebook on the left, and then, a new tab for the documentation. So you'll see another feature here is up at the top. I've got my navigation bar. So if I want to jump to a section, I can just click on all sections and then jump to a specific section. In each section, in addition to the general text and explanation for what's happening, so for this one it would be lists, we have some common vocabulary that you can use as an educator when you're referring to these things, or these are the functions that were referred to. And then we have the exercises. So what's nice here is that it just like a textbook, you as the educator aren't being required to create your own exercises. Obviously you can, and we encourage you to do so, but for all of our sections, we have developed exercises that correspond to that section. Now here in the future, this will look a little bit different, where if you click on exercises, it'll open up a new exercise notebook, but that'll happen here pretty soon. But in the meantime, this is the format that you'll see if you visit the programming lab. Like I said, it's really nice to be able to just use the exercises that are already there and have your students work through it to get a really firm grasp on the Wolfram language. Down below those exercises, we have common sort of question and answers. So something that your students might be thinking, or that you might be thinking, how does one read the list 1, 2, 3 out loud, and so on and so forth. We also have some tech notes. So these are just, extra information. You can think of these as more details that you can find in the explorations. But these are just for the section in the elementary introduction. And then if you do want to close the book, you can see that it's highlighted up in the navigation bar up in the programming lab. So if I click on it, it will close. Open it up. Rounding out what's available on the home page when you get to the programming lab, we have a link to create a new notebook. We have a link to the full documentation, which I mentioned before. And we also have a link to the community. The Wolfram Community is an excellent resource for both educators and students. For educators, you can go here to share content, and I've encouraged other educators to do that as well. And then as a student or as a teacher, if you have a particular sort of tech question or a coding question, you can list it here as well. So it automatically filtered me to the Wolfram Programming Lab group, and then I can start a discussion. All I have to do is sign in. So if I sign in, I can start a discussion and ask a particular question, maybe about a function or an exploration. And our users and monitors for the community are fantastic. Just either it was last week or the week before, I was at a hackathon at the University of Illinois, and a group of students came up to me and asked me, oh, hey, how can I do this? And I had a general, understanding about how they would go about it, but I immediately went to the community. I posted that question, and within the next few hours got a response and was able to pass it along to those students. Okay, I think we've got a couple of questions here, and I do want to make sure we have time for Q&A. So I'm going to go ahead and end my demonstration piece of the programming lab. I'm sure we'll see more of it here as we answer questions. Oh, we've got a question here about what should be in the knowledge base. We are always always adding to it and looking for suggestions on what should be included in the knowledge base. So one of the things what I'm referring to is, you'll notice, let me try to go back here. So in the knowledge base, let's say I hit Control equals and I say population of France. That's pulling from our knowledge base and bringing it into the programming lab or bringing it into my notebook. So we develop and add to the knowledge base based on users, based on where we see the applications for the Wolfram language going. So we're always expanding upon that. So if you do have any suggestions, I think that would be an excellent thing to pass along. Oh, here's a nice question. Why is the mistake still in the code? And I think that's referring to, if I go back to an exploration, let's say that, let me close that. So let's say that oh, no, not that one. So I asked my students, okay, besides a red sphere, I want you to generate a blue sphere or an orange sphere. And they give me this. Oh, obviously you've got an error because you've got the big red box of death here. So we want to make sure that we fix that. If the students don't know where they went wrong or how to fix it, they can click on the restore input and then it generates the original line of code. Why is the mistake still there, or why is this still here? It's really nice to be able to compare. Where did you start off with? What was the original code? And what's different about your code? So this is where I go back to. As a teacher, I don't like to tell them the answer. I'm sure you all know that. You don't want to say, oh, you just capitalize it. You want them to figure it out. Let them struggle a little bit to say, okay, here's what it looks like in the original code. What's different about my code that makes it incorrect? And then they can see, oh, well, the red here is in black and my orange is in blue, and oh, this is capitalized, and oh yeah, I remember, Mrs. Rose was saying that everything, all Wolfram language, it needs to be in capitalization for the Wolfram language to understand it. So okay, now I get it. Okay. So that's something that is available, that we like to be able to compare both the original code and what this student is looking at. Rob, do you want to take a stab at some of the questions that I think you were looking at?
Yeah, sure. We've had some good questions so far. So I was just in the middle of answering one right now. Mahmoud asks, can it solve complex Maxwell equations in electromagnetics? Yes. So the Wolfram language, in principle, can do that stuff. I did my PhD in physics using the Wolfram language. Many people do. Lots of Nobel-winning research is done in the Wolfram language. But the programming lab specifically is really geared towards learning the language. If you're using, especially the free versions, there are limits in the cloud computations and the notebook limit that you can create, and all of those are designed to get you to provide a good environment for learning the language. If you really want to do complex calculations, and you're at the point where you know how that should be done in the Wolfram language, then you want to move on to one of our more technical applications like Mathematica, probably. Let's see here. We've also had a lot of questions regarding how does the Wolfram language compare with other languages? We get asked this a lot. With the programming lab, we're making the statement that the Wolfram language is a great first language. Normally, students will start off with Scratch or block-based programming or something like that, and then there's a sort of abrupt jump. Students will spend time in Scratch, and it's colorful and it's fun. I'll give you that. But then fairly quickly, it's like, okay, well, try Java, and it's a very different experience from Scratch. And so we like the Wolfram language because it doesn't have the sort of dichotomous feel of going from a block-based language to a, what you might consider a professional language. The Wolfram language is a professional language, but it is also easy to use, and they don't have to be mutually exclusive. As you saw when Adriana was showing you the code, it's all written out commands in fairly easy to read language. I would joke with my students whenever I teach the Wolfram language that if you want to know a function, you're trying to think of one, just type it out and maybe it exists. Like, oh, I want to integrate. I'll bet that's called integrate. Oh, it is. Great. So it's very easy to pick up. The syntax is very small. There are only a few things you really need to learn. Square brackets do a certain thing, curly brackets do a certain thing. And once you get that structure just nests inside of itself. It is not really a procedural language like C and Python and so on. It is a functional language. It is symbolic in nature. What underlies the Wolfram language is basically a big table of patterns. And so when you write a function out, it checks it against patterns and does all these transformations on it. And it's a very different experience than using for loops and do loops and so on. Those are in there. You can do all that same stuff with the Wolfram language, but it's not the best practices for Wolfram language. The Wolfram language is designed to automate a lot of that out. When I solve differential equations, for instance, in the Wolfram language, I don't worry as much about the algorithm. I just select it and in the code, and it knows the algorithm for me. That kind of stuff. So it is a very different experience. It is a professional language, but it is still easy to pick up. Let's see here what other questions we have. We had some questions here about the different types. So we've been looking at the cloud-based versions, and as Adriana said, there is the free version. You go and you just sign up and you can just use it. You obviously can't save anything because you haven't logged in. You can sign up for a free version when you log in. That will give you, say, 5 notebooks that you can save. I'm going to go ahead and share my screen again so we can show you some of the limits. So when you sign in for a free account, you can go ahead and save notebooks, but it's limited. Then once you want to save more notebooks, you're really ready to tackle the language, that's when you would be moving towards the paid accounts. So Adriana talked about how to get there. There's the open cloud and the signed in cloud. Then what do you do once you're there? Like I said, once you start really in earnest wanting to learn the language, creating your own files, you want to work through the elementary introduction book, you want to create your own explorations or assignments for a class, that's when you want to start saving files, and that's when you want to upgrade. I would say the standard version will fill most people's needs, at least in the beginning, if you're just an individual trying to use it. The standard version also comes with a desktop client. So we've worked really hard to make the Wolfram language work well in the cloud, and is a feat of engineering, but there's still just stuff you can't do in the cloud, and it's always going to be a nicer experience working in a dedicated desktop environment. So by downloading the Wolfram Programming Lab for desktop, which you would get with a standard plan and above, then you can get more explorations that involve features that you can't do on the cloud just yet, and you can have a more stable sort of computing environment if you're doing things like Maxwell equations, which again you shouldn't be doing in Programming Lab. But if you're a teacher and you want to incorporate Programming Lab into your classroom, we are building a whole suite of tools designed to foster that student-teacher interaction and to bring Programming Lab into the classroom. For those, you'll want a premium account. Okay, and then just really quickly, these are all links to what Adriana showed you, so you can you'll get access to this notebook after the presentation. It'll take you to the community page that she showed, as well as the home page, which has Q&As in case there's anything that we didn't get to cover or anything like that. Let me go ahead and show you that. So this is the home page for the programming lab, and as you'll see, it has a sort of catalog of all the explorations available in the cloud, so you can check them out. So these are not interactive, but they show off everything that you'll be doing. And then we also have Q&As for students and educators that you can look through when you get a chance. There's a lot of stuff covered here, and if there's any questions you have that we don't cover here or in the Q&A session, feel free to email us, give us your feedback. We'd be happy to answer it there. Okay, let's see. Are there any Adriana or Aisha?
Yeah, I've got some questions that I can answer. I really like how people are asking a little bit more about, how do I do this thing, or I found this interesting. One of the questions that was asked is, how do I search words in other Wikipedia languages? So I didn't know the answer to that, but I was, for sure we would have something about it. So I just started typing Wikipedia data, and then I hovered over it and opened up the documentation, and I'm scrolling, and there's all this information, and then here's some information about other Wikipedia language versions to include. So let's say that I ran Wikipedia data for the Dracula article, and what other languages are available? So here are the other languages that are available for the Dracula article. Now, if I actually wanted to grab those articles, I would actually use the parameter language URL rules, and so this is going to return the first two. So this is the link, that is the link to the Arabic article, and this is the link to the other article. So you can just copy and paste that, or if you're doing it programmatically, so this is the key and this is the value and associations, and you can look that up on your own time, but the information is there. It just takes a little bit more code to bring in other non-English articles. There was a question that Brian had asked, how long will these URLs remain available? I'm not quite sure when you asked that, so I'm going to answer two versions that might be possible. If you're signed in to the Wolfram Programming Lab and you click on an exploration that you already started, it will always know that you started this before. So that if you were referring to, how long does my saved exploration last, this one lasts forever. Now, if you were referring to, cancel that, if you were referring to the deployed URL, so let me go back to the Wikipedia, I'm going to resume that. If you were referring to the URL that was produced down here, scrolling, loading. So this link here, because I'm in the free account, it'll last about 30 days. So this link will be available for 30 days. Obviously your code is going to stay, but this link, like I said, because it's in the free tier, it'll only last for about 30 days. If you're interested in having links that are permanent and will never expire, then that is definitely a reason to check out some of our paid tiers that are very affordable both for individuals and for the classroom use. There was a question here. Let me scroll. Maureen asked, is there a way for students to trade code within the lab? That's a fantastic question because, as you've seen or perhaps can envision, when you're in a computer lab and students are working on this, they're always talking to each other, which is fantastic. It gets a little loud, but it's great. So they're collaborating on, oh, here's what I did. I switched this around. Instead of 2 lowercase, I made it 2 uppercase. And oh, I added a title to my form, or I added this, that, and the other thing, and you'd like to share it. Because we're in the free tier, that's really, either looking at somebody else's screen to take a look at it, to be able to, email it to them. How you really want a classroom environment is with a classroom license. And so I believe Rob mentioned that. Let me see if I can get over there. Once you get up into a classroom version, then collaboration and the ability to create and manage groups becomes possible. So this is really the tier that we're looking for, and including site licenses, where there's that seamless connection, passing code back and forth and being able to share it with their classmates. Another question that I say, I saw that David asked, do you know any lines of code that would really wow a group of high school teachers? It just kind of depends on who you're looking to impress, but a really nice resource here is the Wolfram Language Code Gallery. So it's wolfram.com/language/gallery, and we'll put that somewhere. And so these are some pretty short pieces of code that have a lot of powerful impact. And so one of my favorites here is detect faces in real time. So this is something that we did a few years ago. Yeah, okay, yeah. South by Southwest in 2014. And so this is all the code that you would need to draw little red squares around faces in real time. So you can have your computer camera on, and these people can be moving around, and that red square would track them. A friend of mine did something similar. It's a little bit funnier. So instead of red squares, they put like a mustache, and so if your face came into the screen, this mustache or a pair of sunglasses would pop on your head, and no matter where you moved your face in the screen, that mustache or sunglasses would follow you around. So again, that's what, kind of 4 lines of code? Not even. I'd probably consider that maybe just 1. So that's pretty powerful capabilities in just a short amount of code.
So there's a question here. Would you say that Wolfram programming language can perform a variety of complex things in a simpler way? Yes, I would definitely say that. One of the main points of the Wolfram language is that it's a very high-level language. And our founder, Stephen Wolfram, he likes to say that the Wolfram language is, a sort of language of the future, because it is automating more than most languages do. In the same way that, there are a lot of parts of your car that you don't necessarily know how they work, because it takes care of all of the nitty-gritty details, but yet you still need to know some basic maintenance principles. We sort of feel like that's the future of coding, and for most people, we'll still need algorithm developers. We'll still need people to, what I want to say, optimize, Rungakata and stuff like that. But for most people, they don't need to be bogged down in all of these gritty details. They just want something that at the high level they can use and solve their problems. Let's see what else. We have just a few minutes left. Oh, we have so many questions. Yeah, if you guys see any that look good, feel free to jump in.
Lucy asks, can you create PowerPoints, worksheets, or assessment sheets with the program? So we really wanted the programming lab, or at least this current iteration, to be a tool that you use in the classroom. So this is the tool that you can use, and if you're at the appropriate tier, you can manage sort of handout coding exercises, or notebooks with your own code in them. Create one master copy for you, and then give all of your students one version of it. So there is that ability to sort of pass assignments or assessment back and forth between the teacher and student if you're at that appropriate tier. But we didn't want it to explode into a learning management system. So we still want it to remain true to its core, that this is a online programming environment, and there should be some collaboration and communication between the teacher and student, but we don't want it to get sort of clogged down by those other things that you might find in other tools.
There's a question here saying, at the moment, an area of interest is amateur cosmology, and they want to know that if they master the cosmology part, is the Wolfram language a good place for them to explore the cosmological questions? Yes, and at various different levels. As far as the programming lab goes, remember the programming lab is designed to teach the language. There's a lot you can do with just sort of basic code. If you look on the demonstrations project, which is another Wolfram site that is great for snippets of code, I actually have a demonstration looking at gravitational lensing that is something that a student could do if they knew the math behind it. Moving forward, like I say, after you've left the programming lab, you've graduated, and you're a full-fledged Mathematica user, say, and you're doing research. I know a lot of cosmologists that do their work in the Wolfram language. I did some astroparticle cosmology in the Wolfram language. It is certainly viable, anything from the student level all the way to professional.